Now the next article is properties of a triangle. So if we say what is the verbal meaning of trigonometry, that's the science of measurement of a triangle. That is to learn the property of triangles. That is the relationship between the parts of triangle, that is angles and altitude, at the sides of a triangle. What is the relationship between these? What is the relationship between the angles and the sides of triangles and with the trigonometric ratio? So in this article, we shall get the exact relationship between the parts of a triangle, that is angles and sides and vertices of a triangle, by deriving the sine and cos relation, that is sine relation and cos relation between the, that is also called sine rule or cosine rule, which creates the relation between sides or length of sides and angle included at sides. So let triangle ABC be circumcircled by a circle whose radius is capital R. So first of all, we will draw a circle that circumscribes our triangle ABC. So this is a circle. So this is O. This is its radius R, and this is vertex A. So opposite side give its length A. This is vertex B. So opposite side give its vertex length B. This is C. Opposite side give its vertex of length C. So this is all about the triangle. So let measure of angle BAC is equal to capital A, measure of angle ABC is equal to capital B, and measure of angle CAB is equal to C. This is the general values of a, or general properties of a triangle. And also we know that sum of three angles of a triangle is 180 degree, that is A plus B plus C is equal to 5. And let, as we described, AB is equal to C, BC is equal to A, and CA is equal to B. These all conditions will be held while driving the, when we are going to drive the sine formula, sine rule and cosine rule. So first we are going through our first rule, that is a sine rule. What is our sine rule? In triangle ABC, A over sine A, that is side and opposite angles, that is A over sine A, is equal to B over sine B is equal to C over sine C is equal to double the radius of given circle. So we have to prove this relation. If we prove only one relation, A over sine A is equal to 2R, next the relation will be equal and it will be similarly proved. So here we have to prove A over sine A is equal to 2R. Another two, will be proved in the same manner. So after proving this first result, we can take the result from these results. So there are three possibilities. For angle A, that is, first one is angle A may be lying in 0 to pi by t, that is acute angle. It is equal to pi by 2, may be a right angle, or it may be a obtuse angle, that is angle between pi by 2 to pi, that is greater than pi, that is obtuse angle. So we are going to discuss first case. So case 1, that is when the angle is between 0 to pi by 2. So what happened? Suppose O is a circumcircle of triangle ABC, and let BO intersect the circle at D. That is, we are going to draw the diagram. That is, we have a circle, we have triangle ABC, that is radius R. It cuts the circle at the point D. Here, as it is passing through the origin, so BD is equal to 2 times of radius, and D is the measure of angle BDC, or measure of angle CAB. Why it is equal? Because CAB is A, because angles in the same segment are always equal. So these angles are in the same segment. So this angle is equal to this angle. That is, angle A is equal to angle D. So in triangle BCD, if we see BCD, measure of angle BCD is, this angle is 90 degrees, because angle on the semicircle, that is angle made by diameter and other two sides in the semicircle. So it is the angle 90. So it is 90, then sine D is BC over BD. That is, it is a base, it is a perpendicular over hypotenuse. We take this part and we will understand. That is, if we have, this is our circle and this is our B and this is D and this is C. C is taken as right angle and this is a base. If this is base, in this, if this is C and this is base, then sine of D will be, that is, BD over perpendicular over BC over, that is perpendicular, over hypotenuse, that is BD. And what is BC? BC is A and BD is 2R. And also we know that measure of D is equal to A. Therefore, sine A is equal to A over 2R. That is, we get In this case, A over sine A is equal to 2R. Similarly, we can prove B over sine B is equal to 2R and C over sine C is equal to 2R. So when A lying between 0 to pi by 2, we have A over sine A is equal to B over sine B is equal to C over sine C is equal to 2R. Result whole, and this is called sine rule when A is lying between 0 to pi by 2, that is A is an acute angle. Now we will discuss the case that is when angle A is equal to pi by 2. So triangle ABC is right angled, that is A is equal to pi by 2 and BC is the diameter of the circumcircle. So that angle A is pi by 2 because any angle that is formed with the help of diameter, that is semicircle angle, is always pi by 2. So we draw the diagram. This is R circle, this is center, this is BC and this is A. So this is angle pi by 2. So this is R radius, this is R. Also BC is equal to that is our A, which is equal to 2R. So as sine pi by 2 is 1. So we can write A is equal to 2R into 1. That is A is equal to 2R into sine pi by 2. And as pi by 2 is equal to angle A, therefore A is equal to 2R into sine A. So we can see here A over sine A is equal to 2R. That is similarly we can prove B over sine B is equal to 2R and C over sine C is equal to 2R. For angle A is equal to pi by 2 or B is equal to pi by 2 or C is equal to pi by 2, result is true, that is A over sine A is equal to B over sine B is equal to C over sine C is equal to 2R. That is sine rule holds when angle is pi by 2. So next case, that is case 3. This is case when angle A is lying between pi by 2 to pi. So in this case, as angle BAC is obtuse, so vertex A is on minor arc BC, that is C just here. This is our circle. As A is obtuse, it is greater than 90. This is B, this is C, this is A. So A is lying on the minor arc of BC, and let A dash be any point on major arc BC. That is, A dash is here. Now, as we know that it is a quadrilateral, in a cyclic quadrilateral, sum of opposite angle is pi by 2. Therefore, measure of angle A plus A dash is pi, that is 180, not pi by 2, it is 180, because sum of a quadrilateral is 360. So, in the cyclic quadrilateral, sum of opposite angle is pi. Therefore, angle A dash is equal to pi minus A, that is less than pi by 2. That is, as A is lying between pi by 2 to pi, therefore its value is less than pi by 2, it's understood. So by considering case 1 as A dash lying between 0 to pi by 2 and apply the case 1 to triangle BA-C, we get BC is equal to A, that is 2R sine A dash, and sine A dash means pi minus A, and sine pi minus A, that is lying in second quadrant, and as it is varying on pi, so it is again sine A. So we get in this case also A over sine A is equal to 2R. So in each case, or similarly, we can prove B over sine B is equal to 2R and C over sine C is equal to 2R when B and C are angles lying between pi by 2 to pi. So in each case, we get sine rule is followed, that is A over sine A is equal to B over sine B and C over sine C is equal to 2R, that is the constant quantity as radius is constant of a circle. So this is a sine rule that is derived and that creates a particular exact relationship between the sides and angle opposite to that side, that is called sine rule. Now the next exact relationship that will be exist when we derive the relation between sides or length of sides of a triangle and the cosine angle. So what is cosine rule? That is, in triangle ABC, we have cos A is equal to B square plus C square minus A square over 2BC. Cos B is equal to C square plus A square minus B square over 2AC, and cos C is equal to A square plus B square minus C square over 2AB. So we have to derive these cosine rules. So we will prove only first rule and other rules will be similarly proved. So we shall prove here cos A is equal to B square plus C square minus A square over 2BC. Let vertex A as origin, that is 0, 0, and AB in positive direction of x-axis. That is, just see here, this is x-axis, this is y-axis, and we take A as origin and B on the positive x-axis, let it is at a distance C. So coordinate of B are C, 0 and let AB is equal to C. So coordinate of B as we described C, 0, y coordinate is 0, and now take a point C in the plane, that is in the xy plane, such that AC is equal to B and measure of angle CAB is equal to A. That is, if we see here and BC length is equal to A, that is the opposite of vertex A, and it's obvious AC is B, opposite vertex of B, and AB is of length C. Let's make it here. This is A, this is B, and this is A, opposite vertex, and measure of angle CAB is A. So to get coordinate of C, just draw a perpendicular D here such that we will take this triangle. Now to get coordinates of C, so we draw just C, this is x-axis, this is y-axis, and we have this triangle, and we draw here D, this is B, this is A, and this length is C. This is A with coordinate 0, 0, and this is coordinate C, 0, and this is point C. Now as it is perpendicular, that is 90 degree, therefore sine A is equal to CD over hypotenuse, that is AC. So we get CD is equal to B sine A, and cos A is equal to AD over B, that is base over A. So AD is equal to B cos A. So if we see coordinate of CR, this is the x point and this is the length, that is this is the y point. CD is the length and this is the breadth. This is the x coordinate, this is the y. Therefore, coordinate of CR, B cos A and B sin A. And now we have A is equal to BC. On squaring, A square is equal to BC square. That is, now we find out the BC square, that is by using the formula of distance formula. BC square is x1 minus x2 whole square plus y1 minus y2, that is 0 whole square under root. There should not be under root and square will be cancelled out. So we get A square is equal to B square cos square A plus C square minus 2BC cos A plus B square sin square A. So we get A square is equal to B square is common, cos square A plus sin square A plus C square minus 2BC cos A. So we get A square is equal to B square plus C square minus 2BC cos A. That is, we get we get 2BC cos A is equal to B square plus C square minus A square. That gives cos A is equal to B square plus C square minus A square over 2BC. Similarly, we can prove cos B is equal to C square plus A square minus B square over 2AC. If you see, we use a trick. If you find out the cos C, just take opposite part, that is B and C, B square plus A square minus of this angle C square over product of these two. So this is all about the cosine formula, and this is the exact relationship of the trigonometric functions and trigonometric angles and the vertices or sides of the angles. That is the exact relationship between the different parts of a triangle.